All right, guys, welcome back. Today we have Unit 1, Day 5. This is midpoint formula, and it's kind of going to build off of distance formula, and that there's an algorithm that we'll be using. And then we're also looking to kind of derive some characteristics of the relationship between 2 points in the coordinate plane. So a midpoint, we say this is the middle point between 2 endpoints. So that's just the most general way to define that. If we're on a straight line, it's pretty straightforward to just take essentially the average of the points and find what's smack dab in the middle. If we're dealing with something in the coordinate plane, like in this scenario, it takes a little more calculation and thinking through the process to find, okay, where is this one located? Because we're not able to just count in, if that makes sense. So the formula that we will be using for midpoint is the x. So it actually is going to give you an ordered pair as an answer. So you add up your x values together, divide by 2, and then add up your y values together, divide by 2. And so it's going to give you a new x and a y value. So it's kind of like you're taking the average of each the x pairs and the pair of the y's as well. Okay, midpoint on a line is literally just the average between them. So you would just add x1 and x2 together and divide by 2. So for example, if this is at, let's just do like a really easy example, -1, and this guy's at +1. Notice that if I do -1 plus +1 and I divide it by 2, that's 0 divided by 2, which is 0. So that is in fact at 0 on a straight number line. But again, it gets a little crazier with a coordinate plane because you're having to take the average of both the x's and the y's independently and then link them together as an ordered pair. So let's see how this would work on a number line. So if we want to find the midpoint of xy, so xy is linking x and y here. This is the actual line segment. I want to find the midpoint. Notice that x is at -1, y is located at 7. So again, I'm taking the average of these points. So we could say that the midpoint is just -1 plus 7 divided by 2. So that's 6/2, which is 3. So if I were to count in, notice 1, 2, 3, 1, 2, 3. We're trying to close in fourth, boom. 3 is our midpoint. So that's kind of an alternative strategy. So you can count in from both sides to see where you land as well. Okay, WZ would be, so here's the endpoint 1 and 2. So this is the line segment. And I want to find the midpoint between. So I could try that counting method. So 1, 2, 3, 4, 1, 2, 3, 4. Oh, and notice that we're going to have to be a half unit in. So this is like right in between -1 and 0, which would be -1/2. Just to show you how this would work as well with using the endpoints of -5 and 4. If I add those guys together, -5 plus 4 and divide by 2, this gives me -1/2, which is exactly what I got here. So again, you can use the counting method or just average the 2 endpoints. So think of the process in a coordinate plane as essentially taking just 2 averages. So if I have points here, I'm going to roughly sketch it. M's at 1, 1, 2, 3, 4. So somewhere over here. N is at 1, 2, 3, 4, 5, 6, 7. And then 6, so somewhere up here. Obviously, I can't use counting method in this case. I definitely will have to use midpoint formula. So we'll say our midpoint formula, which is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So again, think of it as taking the average of both the x's and the y's. If we label our points, x1, y1, x2, y2, and then pop those guys in, then we have 1 plus 7 divided by 2, and 4 plus 6 divided by 2. Simplifying, we have 8/2 along with 10/2. And so that's actually just a 4, 5. So again, it's just an average between the x values and the y values, and then you link them together as an ordered pair. Okay, and then we're going to do the same thing for these guys. So finding the midpoint between A, which is at 3, 5, so somewhere over here, and then B is at -3, 13, somewhere way over here. straight line distance, or sorry, whoops, that's distance formula. We're trying to find the midpoint between the two. So we want to find like where is the midpoint. So again, let's designate x1, y1, x2, y2 so as to facilitate our formula, which we know is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. You're just popping those numbers in, simplifying. So 3 plus negative 3 divided by 2. 5 plus 13 divided by 2. Oops. And so we get 0 over 2, comma, 18 over 2. And let's just take it over here. It's just 0, comma, 9 as our midpoint. And there we have it. And look, that was kind of our prediction here, is that the midpoint would be on the axis anyway. Okay, next one. C is at -4, -7, so somewhere over here. And then D is just like way over here. So something like finding, again, the midpoint between those two. So we want to designate x1, y1, x2, y2. And we know we're finding the midpoint. Formula being x1 plus x2 divided by 2. y1 plus y2 divided by 2. And then plugging our numbers in, we have -4 plus 0 divided by 2, along with -7 plus 15 divided by 2. So really what we're looking at is -4 divided by 2, along with 8 divided by 2. And so that simplifies as -2, comma, 4. Okay, so up to this point, we've been working forward in that we've found the midpoint from when we're given two ordered pairs. Now these next ones are going to have us work backwards. We want to find the coordinates of A if we know B and we know the midpoint between the two. So if we kind of get a rough sketch, B is at 10, 8, so somewhere over here. Midpoint is at 7, 10, somewhere like up here. This is the midpoint. And then we want to find where A is. So again, we have to kind of think backward. Okay? So we could set up an advanced we'll say like set up an equation, two different equations to solve. Or if we just consider that, well, to get the midpoint, we ultimately were adding two numbers together and then dividing by 2. So the opposite would be to, so let's go through that again. So in order to get these two numbers here, we had to add two numbers together and divide by 2. So the opposite would be to multiply by 2 and subtract the corresponding x or y, depending on which value we're looking at. Okay, so if I want to find, okay, what other point would have generated 7 as a midpoint, then I'm taking 7 times 2. That gives me 14. Okay, so I know that, again, two numbers are added together and divided by 2 generated 7. So I have to work backwards. So I multiply by 2 and then subtract out. Notice that, let's get a different color here. This is my x value. So I'm going to subtract out the 10, which was the other x value, to get 4. So that was, we're looking for point A. So for point A, the first value is a 4. Okay, we're using that same trick for finding the y value of A. So I'm going to take 10, double it, so 10 by 2 is 20, and then subtract out the y value that we already knew about. So 20 minus 8, that's 12. And so we know that point A is at 4, 12. We can always work forward to check our work, meaning if I take 4 plus 10, that's 14, divided by 2 is 7, so that checks off. 12 plus 8 is 20, divided by 2 is 10, so that checks off. Okay, and then similar process here, we want to find the coordinates of the missing endpoint. If E is the, finding the coordinates of the missing endpoint, yeah, if E is the midpoint. So we want to find F over here. So E is in between D and F. Okay, so same thing. We're going to double both of these numbers because we're working backward. So this gives me a 2, this gives me a 4, and then we'll subtract out the corresponding number. So in this case, I want to subtract -3 because that's the x value. And then from 4, I'm going to subtract -8 because that's the y value. Right, so notice that this becomes addition when I subtract a negative like this. So this is actually going to be 5. And this also becomes addition here. So 4 plus 8 is 12. So point F is at 12. Remember, we can always check our work by doing midpoint formula on D and F, just to make sure it checks off. So -3 plus 5 divided by 2, that is 1. Boom, that checks off. And then -8 plus 12 divided by 2, that's 2. Boom, that checks off 2. So the final answer, this was the missing endpoint of F. Okay, same thing here. We want to find, we're finding the missing endpoint if E is the midpoint. Here we have F, so we need D. That's what we're looking for. So same thing, we want to double the midpoint values. So times 2, times 2. If I take 5/2, let's do this to the side because it's kind of messy. So 5/2 times 2. When I'm multiplying a fraction by a whole number, we want to normalize this, make that a fraction. So this is actually 10/2, which is 5. 6/2 is 12. And then remember, from those doubled numbers, we're now going to subtract the values that were given to us. So subtract the 5 to get 0. And subtract the 11 to get 1. So that makes D 0, 1. And just to make sure that, in fact, E is the midpoint between these two, let's just double check. So 5 plus 0 divided by 2, that's 5/2. Boom, checks off. And then 11 plus 1 divided by 2, that's 12/2, which is 6. That also checks off. Okay, now we're looking at a straight line distance. We're told in this figure B is the midpoint. We want to find the value of B. So this is just a property that actually should have established at the beginning, up at the top here. Maybe let's go back in up here and say not only is the middle point between the two endpoints, but it cuts the line segment perfectly in half. Later in our content this year, we'll learn that this term is also known as bisect. So to bisect means to cut something perfectly in half. So if I know that back down here, I have this line segment that's being bisected by what is its midpoint, then these two expressions have to be equal to each other because they're the same distance. So I know that 3b plus 4 equals 5b. And then now it's just an algebraic equation to solve. So if I subtract 3b, these cancel. So we have 4 equals 2b. Divide both sides by 2. And we find that b equals 2. So there will be in our future this year a lot of embedding of algebraic equations in our geometry content. So there we go. Okay, another application problem. So now we have Paul and Susan, lost it. Paul and Susan are standing outside City Hall. So again, let's make City Hall at the origin. Okay, Paul walks 3 blocks north and 2 west. So 3 north, 1, 2, 3, 3 north, what was it? 3 north and 2 west. 2 west. So as an ordered pair, that's -2, 3, right? Because we always read the x value first. And then Susan walks 5 south and 4 east. So Susan is 5 south, 1, 2, 3, 4, 5. 4 east, 1, 2, 3, 4. And because we read the x value first, that's actually 4, -5. Okay. If City Hall represents the origin, which we already set that up, we want to find the midpoint. So like if the two of them were to walk toward each other, where would they meet? If they're walking the same distance. So remember our midpoint formula is just our x1 plus x2 divided by 2. And then our y1 plus y2 divided by 2. we designate our points, x1, y1, x2, y2, and then pop those numbers in, x1 is -2 plus 4 over 2, and then y1 is 3 plus -5 divided by 2, and so we have 2 over 2 along with -2 over 2. And so that simplifies as 1, comma, -1. So that's our midpoint. Cool. All right. That's not only concludes this lesson, but also the unit. Thanks for watching, guys. Have a great day.